In this video, I'm going to talk about how to perform interference fit analysis in Marc 2013, and I'm going to use Mentat 2013 GUI for this purpose. So here we have two cylinders, the inner one overlapping the exterior one, and you can see the overlap over this area, and we need to resolve that overlap in this analysis. And as you can see, I already have certain boundary conditions specified. These are all these outer nodes, they are fixed. And I also have material properties defined, so I don't need to spend time on that. But the important thing is how to set up the contact analysis or contact setup in this particular problem. So let's go to contact menus and let's create two contact bodies. And elements add. I have a couple of sets defined, so I'm going to take advantage of that and select those sets. And we have two different contact bodies defined at this point. And the next important thing is defining a contact table. And over here we go to contact table, and in the properties, in this case I just need everything to be touching everything, so I just select the T or touching option, so we see T in all the boxes. And this is where we need to perform one additional step for interference fit analysis. So here you see the option of interference fit, and if I go in there, I make that active. And there are various options that you can use to perform interference fit, because a single one may not be appropriate for all types of problems. So we can use contact normal, you can use translation of the nodes, you can scale the part, or you can let the program decide, and there is also a user's built-in option. And for this purpose, I'm going to use contact normal first. And there is an interference of about 0.05, so we need to give a value that is higher than 0.05, and I'm going to use 0.06. And if you give even a higher value, for example 0.15 or 0.2, it is still okay, but Marc might just need to it might take more increments to solve the problem. It is just a matter of increments being wasted and additional computational time spent on it. So remember that if there's an overlap, we do need to specify a negative number here. And the other part is we need to have a table, and so I don't have a table, so I need to go back and create a table. And so one variable, and which is time. And the table would be as follows: 0, 1, so we have a 0.1 there, and then the other one is at time equals 1, it is 0. So unlike a regular ramp function you might use when you're loading, so here it goes in the opposite direction. So because there is an overlap, and at the end we want to remove the entire overlap, so that's why we are starting at 1 and going down all the way to 0. So I go back to contact, and we have the contact table menu. So let's get back here, and I need to select that particular table. So we have, so at time equals 0 we have the overlap of minus 0.06, and time equals 1 everything would be resolved, so there won't be any overlap. So we have the contact table defined. So the next steps are simple. We need to define a load case. So under properties, we just need to make sure that our contact table is selected. Do that. And I'm going to use 10 steps here. This is not very bad, so it should be able to resolve even earlier, but I'm going to use 10 steps anyway. And then after that, go to jobs, and make sure I select that particular load case, and under contact control, once again I select the same table where we can go to the initial contact and select the contact table. And we at this point we don't need to do any other changes. And let's go to large strain, because the strains are going to be large. And under job results, you can select any results you want. For example, I select stress, let's say, and click on OK. And for element types, it is going to be planar and the solids. So I'm going to choose element 11 and use all the elements. So we are set for the job setup. So we just need to run this model. So let's go ahead and run it. And it takes just about a couple of seconds. So it is finished. And let's open the results file. And I'm going to just play it. So you see that slowly we see that overlap going away. And at the end, we have everything set. And if you want, we can also check the any of these results that we may have. For example, if you look at contact status, you see that there is contact all through. And another way is, as I mentioned earlier, we can use an automatic approach or any other of these options like the translation or scaling. Let me show how automatic would work. So here again, you can specify a tolerance, or you can let the program decide what the amount of tolerance. And I would go ahead and select the same table. And I'm not specifying any value even for the amount of overlap here. So that is all I am changing here. And let's see how that would work. So it is the same. The load cases and everything, they are set up. I'm using the same contact table, so I'm not changing anything. So let me go ahead and run it with the automatic approach. So it has finished. And once again, let's play the results. So you see the same thing happening again. So let me, if you look at the contour bands, once again, you see the contact all through for all these nodes and all these segments here. So that is how you can perform an interference fit analysis in Marc and Mentat 2013. Thank you very much.